Today, we are going to pull back the curtain on one of the unsung heroes of your internet connection. It's the process that gets you online in just a matter of seconds.
You know the feeling, right? You pop open your laptop in a coffee shop, you click on the Wi-Fi network, and bam, you're online. It honestly feels like magic, but it's not. It's actually a really efficient process that's always happening in the background, and we're going to show you exactly how it works.
I mean, think about what it would be like without this. You'd have to be your own mini network administrator every single time you wanted to connect. You'd be sitting there manually typing in an IP address, a subnet mask, a default gateway. It would be a total nightmare, and it really shows you the problem that needed a simple solution.
And that solution is DHCP. It stands for Dynamic Host Configuration Protocol. And really, it's just an automated system designed to hand out all the essential network info, making that seamless connection totally possible.
So how does this protocol actually hand out these digital addresses so incredibly fast and effectively? Let's dive in.
The thing is, DHCP doesn't just toss your device a single IP address. It hands over a whole welcome package. This thing has everything your device needs to start talking on the network. You know, its own unique address, a map of the local neighborhood, and the main gate to the wider internet. The entire exchange is basically a very fast, very structured conversation. So on one side, you've got your device, that's the client. And on the other, you have the network's DHCP server, which is just sitting there waiting to help out. Now, this conversation, it follows a very specific four-step process. It's often called the DHCP handshake.
The whole thing boils down to 4 key steps: discover, offer, request, and acknowledge. Some people remember it with the acronym DORA. So let's take a look at how this high-speed little chat actually plays out.
Okay, so it all kicks off with that first step, discover. Your device broadcasts what's called a DHCP discover message. It's pretty much shouting out to the entire local network, hey, is there a DHCP server out there that can help me get online? Next up, any available DHCP server on that network will reply with a DHCP offer. This message is a direct response, basically saying, yep, I'm here and I've got a whole network set up for you, including this specific IP address. Now, if there are multiple servers, your device might even get a few different offers. So now your device has to make a choice. It picks one of the offers, usually just the very first one it gets, and then sends out a DHCP request message. This tells the server it picked, hey, I'd like to accept your offer. And it also quietly lets all the other servers know that their help isn't needed this time. And finally, the server makes it all official by sending back a DHCP CAC, which stands for acknowledgement. This message confirms all the details and finalizes the whole deal. The handshake is done, and your device is now officially on the network. But what happens when you're done and you close your laptop? Well, the process for leaving a network is just as neat and tidy.
So when you disconnect, your device sends a DHCP release message to the server. It's essentially saying, hey, thanks for the address, but I'm all done with it now. The server then takes that IP address and puts it back into its pool, making it available for the very next device that comes along.
So let's wrap this all up. The reason DHCP is so important is that it just makes our digital lives incredibly simple. It's this silent, automatic process that makes sure every device can get on a network correctly and instantly, without us ever having to think twice about it. But here's a final thought I want to leave you with. These IP addresses from DHCP, they aren't permanent. They're more like leases that eventually expire. Your device has to check in with the server from time to time to renew its address. So why do you think this system of constant check-ins is so essential for keeping a network healthy and stable? Thanks for watching.